another experiment. This experiment is about identification of unknown one as one experiment. Based on last week's experiment or qualitative analysis of an unknown compound, you identified the functional group. And today, for this unknown, the unknown will be assigned, only one unknown will be assigned per group of students or individual student, and that depends on your instructor. Your unknown, it could be carboxylic acid, it could be ketone, it could be aldehyde, or it could be alcohol. Start with one of the unknowns, which is my unknown A. The outline of the procedure is, first, we are going to look for appearance of this compound. What is the color of the compound? Is it solid or liquid? And anything that you can write as the observation of the compound itself. Then you're going to measure melting point as one of the physical properties, because later on, when you know this compound is ketone, is aldehyde or carboxylic acid, you have to come up with the name of that compound. So physical property, like specifically like melting point, it can help you a lot to identify what your compound is, to come up with the name of the compound. After the melting point, we are going to determine solubility to determine the functional group. We follow by classification test to confirm the, if needed, the functional group, or further analysis or quantitative analysis in order to determine the name. The more information we have, the better and estimate of the physical property, or better matching of the physical property to literature value, we can determine the name of the compound with more greater confidence. Now, first, I'm going to start with unknown A. Your unknown A is a white powder. I'm going to grind to make it powdered. It's going to react faster in the solubility, and also is going to fit into capillary tube easier. So I hold the capillary tube using close end and tap the capillary tube a few times into the sample. I don't want to touch this part of the capillary tube because I don't want it to contaminate the sample. I pass the capillary tube through a hollow glass tube to bring the sample down. Based on the unknown that we have, this is like, it could be ketone or aldehyde or carboxylic acid, and even alcohol. If it's solid and it's polar, it's going to have relatively high melting point. So I'm going to set it between 4 and 5, but if it melts at 100 or less, then I'm going to do a second sample and set it between 2 and 3. And to place it in the sample holder, turn on the machine and set it between 4 and 5. 4 and 5 on the chart is anywhere between like numbers of 100 to 150. So I'm going to set it between 4 and 5 and monitor the temperature and the capillary tube through this eyepiece. And as soon as I see it's melting, I will take a picture of the temperature with initial melting and the final melting for you. So I can pause the video at this point until it starts melting. It's about to melt, and it's actually very, very nicely. It's kind of, it's shrinking. Now post it for you. Okay. After the melting point, we're not going to have any conclusion at this point based on the melting point, because it could be ketone or aldehyde or alcohol or carboxylic acid. Next, we are going to do the solubility test. For the solubility test, we are going to test solubility in water, 5% HCl, 10% sodium hydroxide, 10% sodium bicarbonate, and sulfuric acid. If the sample dissolves in water, we don't have to do anything. We just have to check the pH to see if it's acidic, neutral, or basic. If it doesn't dissolve in water, then we test the HCl. If it dissolves in HCl, we're just going to stop. So this is based on the procedure. The procedure tells you clearly, if it doesn't dissolve, move on. If it dissolves, just stop or move to the next, if you have to come up with conclusion. So as I said, last lap, I'm just using tip of spatula of the sample. And I am adding 3 full droppers of the solvent. So I have 1, 2, and 3. This satisfies 3 milliliter of the solvent. And I would shake it for about like 10 seconds and to see if it dissolves or it doesn't dissolve. So you could see that the solid pieces are there, and it doesn't matter how hard I shake, it doesn't dissolve. So the conclusion is it did not dissolve in water. We are going to continue to the next solvent. So unknown A did not dissolve in water. Now we're going to test solubility in HCl. Similar procedure to last experiment and solubility in water. And also I want to remind you that because it did not dissolve in water, I don't have to test for pH. With the HCl, I add tip of a spatula of the sample. I'm going to add 3 full droppers. 1, 2, and 3 full droppers. Mix it well. If it dissolves, it would be clear liquid, clear solution. If it doesn't dissolve, you should be able to see the solid that's still in there. Just shake it for like 10 seconds and record your observation. Okay, it's settling down and you have these crystals on the wall or the solid compound on the wall. It reports as not soluble. So it did not dissolve in HCl. Because it didn't dissolve in HCl and water, we are going to test with 10% sodium hydroxide. I didn't add my samples to the test tube because I don't know where to stop. Maybe I have to do all of these. Maybe I can just, if it did dissolve in water, I didn't have to do the rest. So I'm adding the sample into test tube, tip of a spatula again, 10% sodium hydroxide, 3 full droppers of the solvent and mix it for 10 seconds and check the solubility. If it turns clear liquid, clear solution, it's soluble. It looks like it's dissolving here, and maybe with the blue background, see that it is clear. So what happens if the sample dissolves in sodium hydroxide? Sodium hydroxide is base. If the unknown dissolves, that means that it is acidic. And it could be phenol or it could be carboxylic acid. In order to distinguish between the two, is it phenol or is it carboxylic acid, we need to test the solubility in sodium bicarbonate. If it dissolves, that means it's carboxylic acid. Sodium bicarbonate is a weak base. And because it's a weak base compared to sodium hydroxide, that is a strong base. Because it's a weak base, if it dissolves, that means the unknown is the stronger acid of the two. If it doesn't dissolve, it means the weaker acid of the two. Which two we are talking about again, carboxylic acid or phenol. So we're going to check with the sodium hydroxide. Since already dissolved in sodium hydroxide, I'm testing with sodium bicarbonate. If it doesn't dissolve in sodium hydroxide, I do not test for sodium bicarbonate. Okay, sample, so I shake it. Okay. It's not disappearing, but I noticed that there are some bubbles forming at the surface of this mixture. The bubbles clear. If I wait long enough, I could see the bubbles are forming. If I wait long enough, it's going to disappear. But even if your sample does not disappear and you see the bubbles forming at the surface, that means sodium bicarbonate is reacting with your unknown, and that means the unknown is carboxylic acid. If it's phenol, you will not see these bubbles because it's soluble in sodium hydroxide and sodium bicarbonate. This is the characteristic for carboxylic acid. So I do have a conclusion at this point that the compound is carboxylic acid. And in order to find out which carboxylic acid is, I have to check the molar mass. Because if I have the melting point only, the table that it will be provided to you, you could see that there are like maybe 10 different carboxylic acid that they have melting point between 150 and 160. A melting point around 153 or 154, it doesn't help you to pick single carboxylic acid. So we need a second piece of information. The second piece of information is going to be the molar mass for carboxylic acid. No need to do the test for sulfuric acid. For the